Okay, for number 7, we're factoring each of these, and if it cannot be factored, we're calling it prime. So we have to look for a couple things. Common factors, and failing to find any common factors, we then look to see whether we can do the factoring by adding and multiplying, the method that we learned toward the middle of the unit. Okay, so for the first one, 4x squared minus 24x, we certainly have a common factor. We have 4x, which can be divided out of both 4x squared and negative 24x. So we end up with 4x times x minus 6. And so those are our two factors. X squared minus 3x minus 40. There are no common factors. So we need to see, are there two numbers that multiply to negative 40 but add to negative 3? And it turns out that negative 8 and positive 5 fit the bill, so we factor it to x minus 8 times x plus 5. X cubed plus 6x squared plus 9x, the first factorization of that gives us x times x squared plus 6x plus 9. Well, x squared plus 6x plus 9 is a perfect square trinomial, one of the patterns that we really want to be familiar with. And so that factors into x plus 3 squared. So we end up actually with three factors. We end up with x times x plus 3 times x plus 3 again, or x plus 3 squared. Okay, for D, we have the difference of two perfect squares, which always factors to the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Okay, E, we actually end up with the difference of two perfect squares again, except this time our squares are x to the fourth and y to the fourth. So we end up factoring this to the square root of x to the fourth, which is x squared, minus the square root of y to the fourth, which is y squared, and then we also get x squared plus y squared. But this first one here can be factored again, because it's again the difference of two perfect squares. So we end up with x minus y times x plus y times x squared plus y squared, because that cannot be factored. So that's our final factorization. We have three factors. Okay, for F, again, we'd like that you come to recognize this as a perfect square trinomial. If we take half of the middle term, negative 8, and get negative 4, and we square it, we get 16. So since the final term here is 16, this is a perfect square trinomial, and it just becomes x minus 4, again the minus 4 coming from half of minus 8, and that quantity squared. For G, we have x squared that can be factored out of all three of these terms, and we also have a 3. So we end up with 3x squared. What's left is x squared plus 3x plus 5. That can't be further factored because there's no number that multiplies to 5, and two numbers that multiply to 5 and add to 3, they don't exist, so that can't be factored. Similarly, x squared minus 7x minus 2 cannot be factored at all, so that is what we call prime. Okay, for number 8, we are doing some multiplication using the repeated distributive property method rather than the multiplication box method. So what that means is that you take the first term and you take the first factor, you take every term out of the first factor and multiply that separately by everything in the second term. So here, for example, for A, 2x minus 6 becomes 2x times 4x plus 3 minus 6 times 4x plus 3. When we work through that, we get 8x squared plus 6x minus 24x minus 18, and that the like terms combine to 8x squared minus 18x minus 18. Similarly, for B, we're going to have each of the three terms in the first parentheses multiplied separately by x plus 1. So we have x squared times x plus 1, 2x times x plus 1, and 1 times x plus 1. We then go through, multiply it all out, combine like terms, and we end up with x cubed plus 3x squared plus 4x plus 1. Same thing with C. We have x times x squared plus x plus 1, and then we have negative 1 times x squared plus x plus 1. So we have to remember that when we're multiplying this negative 1 times x squared plus x plus 1, that every single sign there changes. So we start with x cubed plus x squared plus x here, But then we have a negative x squared, a negative x, and a negative 1, all of which combines to x squared minus 1 because everything but the x cubed and the negative 1 cancel out. Alright, x to the minus 4 times x plus 5, same process. We end up with x squared plus x minus 20 because we end up with a negative 4x and a positive 5x, yielding a middle term of 1x, or just x. Okay, for number 9, we're finding the solution set. Sorry if this looks a little messy. It's hard with the stylus on the iPad. Okay, for A, so we are looking to see, first of all, if we can factor it, which we can, to x minus 3 times x minus 2, which gives us the two solutions x is equal to 3 and x is equal to 2. Those are the two values that set it equal to 0. Because if either of the two factors, x minus 3 or x minus 2 is 0, then the whole thing is 0. For B, we factor it to x times x squared minus 9 by first factoring out the common factor, and then x squared minus 9 is the difference of two perfect squares, giving us x minus 3 times x plus 3, and that gives us three solutions. So the whole thing is equal to 0 when x is equal to 0, when x is equal to 3, or when x is equal to negative 3. Okay, for C, we first set it equal to 0 by subtracting 24 from both sides. Are there two numbers that multiply to negative 24 and add to negative 2? Yes, negative 6 and 4. So we end up with x minus 6 times x plus 4 equals 0. That gives us two solutions. X minus 6 is 0 when x is equal to 6. X plus 4 is equal to 0 when x is equal to negative 4. Okay, for D, first thing we did was we divided both sides by 2. We ended up with x squared minus 3x minus 10 is equal to 0. You notice that we can do that. We can divide everything through because when we divide 0 by 2, we just end up with 0. So we factor x squared minus 3x minus 10. Are there two numbers that multiply to negative 10 and add to negative 3? Yes, negative 5 and positive 2. So x minus 5 is 0 when x is equal to 5, x plus 2 is 0 when x is equal to negative 2. That gives us our two solutions of 5 and negative 2. Okay, x squared is equal to 64. Well, when we take the square root of both sides, we're going to get x is equal to either the positive or negative square root of 64. And so that, we know, is equal to either positive or negative 8. Those are our two solutions. F is similar. We take the square root of both sides. We get x minus 2 on the left is equal to positive or negative 4. We get the two equations then. X minus 2 is equal to 4, which gives us x is equal to 6 as a solution. X minus 2 is equal to negative 4, and that gives us x is equal to negative 2 as the second solution. And again, if we plug those values in, we can see that if x is 6, we get 6 minus 2 squared. We get 4 squared is equal to 16. Negative 2 minus 2 gives us negative 4 squared is equal to 16. For G, same thing again. We end up with x minus 4 is equal to positive or negative, and this should be the square root of 10. And so we end up with our two solutions as x is equal to 4 plus the square root of 10, and our second solution, x is equal to 4 minus the square root of 10. Okay, and for H, we have x squared plus 6x plus 9 is equal to 25. Well, x squared plus 6x plus 9 is a perfect square trinomial. We get x plus 3 squared is equal to 25, which gives us x plus 3 is equal to positive or negative 5. And so we get as our two solutions, we get x is equal to negative 3 plus 5, or negative 3 minus 5, so we get x is equal to either 2 or negative 8. Those are our two solutions. Okay, down here we're looking for the values of a that make this a perfect square trinomial. Again, the perfect square trinomial has this form, x squared plus 2kx plus k squared. So the coefficient of the middle term, which is 2k, if you take half of that, or just k, and square it, you'll get the last term. Okay, so we have x squared plus 6x plus a. For that to be a perfect square trinomial, a would have to be equal to 6 over 2 squared, which is just equal to 9. So a is equal to 9, makes that a perfect square trinomial. Here, we don't know what the middle term is, but we know that the last term is 25. If we take the square root of that, which is 5, then the coefficient of the middle term has to be double that. So it has to be either positive 10 or negative 10. So we're going to get a is equal to positive 10. We get x squared minus 10x plus 25. And again, that's a perfect square trinomial. Here, for c, we get x squared minus 12x. For it to be a perfect square trinomial, we would have to take half of 12, or negative 6, and square it, which would give us positive 36. So a squared is equal to 36. So a is equal to 6, or a is equal to negative 6. For d, again, we don't know the middle term, but we know the last term is 25. So we know the middle term has to be either negative 10 or positive 10. So we're going to get that negative 5a is equal to 10, or negative 5a is equal to negative 10, which would give us the solutions of a is equal to negative 2, a is equal to positive 2. For e, it's a little trickier. So again, but the way the perfect square trinomial works is that the middle term is going to be equal to 2 times the square root of the first term times the square root of the second term. So that means that negative ax has to be equal to the square root of 4x squared times the square root of 9 times 2, and that's going to give us 2x times 3 times 2, which is equal to 12x. So negative ax has to be equal to 12x, so negative a is equal to 12, and a is equal to negative 12. For f, again, we know the last term is 49. We take the square root of that, get 7. So that means 2a, the middle coefficient has to be double 7, or 14. So 2a is equal to 14, and a is equal to 7. Okay, so for number 11, we're to provide 3 examples of expressions that are the difference of perfect squares, then factor each one. Again, if we take the example here, x squared minus 49, both are perfect squares. The factorization is the square root of the first x minus the square root of the second, the square root of the first x, plus the square root of the second, 7. So, as an example, we can have x squared minus 36, which factors to x minus 6 times x plus 6. X squared minus 9, which factors to x minus 3 times x plus 3. And then for the last one, we have a slightly different example. 9x squared is a perfect square. Its square root is 3x. So we end up with 3x squared minus 4 squared. And that's why we end up with 3x minus 4 times 3x plus 4 is the factorization of this. Okay, so then we have a problem of a bowling ball dropped from the top of a 640-foot tall building. The equation for where that ball will be after t seconds in terms of its height off the ground is given by the equation negative 16t squared plus 640. The negative 16t squared is going to be part of all these equations, and the 640 comes from the height of the building. So if we want to know where it is after 5 seconds, we just plug 5 into our equation. We get negative 16 times 5 squared plus 640, which gives us negative 16 times 25, or negative 400 plus 640, which gives us 240. So it's 240 feet off the ground after 5 seconds of dropping. Okay, how long will it take the ball to hit the ground? Well, now what we need to do is we need to set the height equal to 0, and then solve. So the first thing we do after we've done that is we divide both sides by negative 16, because that's a common factor from negative 16t squared and 640, and we divide 0 by negative 16, which leaves it still 0, and we get the factorization of t squared minus 40. Well, that gives us t squared is equal to 40, which means that t is equal to plus or minus the square root of 40. And that turns out to be about 6.32, so it'll take about 6.32 seconds to hit the ground, or in exact terms, the square root of 40. Alright, in number 13 we add a new element, which is what if instead of dropping the ball we throw it upward with an initial velocity of 96 feet per second. Well, that adds to our equation then this term plus 96t. So now the ball, instead of just dropping, is going to go up for a while and then start to come down. So it's going to reach a maximum height somewhere above the height of the building. Okay, so again, when we want to know where it is, how long it'll take to hit the ground, we set it equal to 0, as we did above. So we have negative 16t squared plus 96t plus 640 is equal to 0. Again, we can divide it through by negative 16, which leaves us t squared minus 6t minus 40 is equal to 0. This factors into t minus 10 times t plus 4 because two numbers that multiply to negative 40 and add to negative 6 are negative 10 and 4. Well, that gives us either t is equal to 10 or t is equal to negative 4. Negative 4 doesn't make sense in this problem, so we have as our solution t is equal to 10. It'll take 10 seconds for the ball to hit the ground. Okay, another form of the equation is negative 16 times t minus 3 squared plus 784. Now this is exactly the same as the equation above, it's just in a different form. So negative 16t squared plus 96t plus 640 is equal to negative 16 times t minus 3 squared plus 784. Well, what this question asks us to do is to use this form to figure out when and where it's going to be at its maximum height. So as we look at this form of the equation, one thing we know is that negative 16 times t minus 3 squared is going to be either negative or 0, because t minus 3 squared can only be either positive or 0, and multiplying it by negative 16 means it can only be negative or 0. So it's going to reach its greatest value when t minus 3 is equal to 0, and that would give us 0 plus 784 as the greatest height the ball will reach. So it starts at 640 feet and it goes up to 784. How long it takes? Well, we can see from the equation that t minus 3 is going to be 0 when t is equal to 3. So halfway, or rather at 3 seconds, it's going to be at its maximum height of 784 feet. Okay, so the last question on this ball being thrown up into the air asks us to figure out how long it takes for the ball to reach its height of 640 feet again, because that's how high it was when it was first thrown, because that's the height of the building. So really what happened was the ball was at the top of the building, was thrown up into the air, reached a maximum height, and started to come down. We want to know how long it took to get back to this height of 640. So we set the height to 640, and then we solve. When we do that, we can see that we're going to be able to subtract 640 from both sides, which will end up giving an equation of negative 16t squared plus 96t is equal to 0. When we factor that, we get negative 16t times t minus 6 is equal to 0. And that gives us 2 times when the ball is at 640 feet at 0, which makes sense because that's when we started, and that's how tall the building is, and then at t is equal to 6. So that's how long it took for the ball to go up and come back down again to reach a height of 640 feet. Okay, so lastly we have number 14 where we're using the completing the square method. So for A, we have x squared plus 10x plus 40. So we know that in order for it to be a perfect square trinomial, we have to have a third term that's equal to half of 10 squared. So that's equal to 25. Well, in order to get this to 25, we have to subtract 15 from 40 to get it down to 25, and that means we also have to subtract 15 from 51, which gets us to 36. So we end up with x squared plus 10x plus 25 equals 36. Well, when we factor, we get x plus 5 squared is equal to 36, which gives us x plus 5 is equal to positive 6, x plus 5 is equal to negative 6, and x is equal to 1, or x is equal to negative 11. Okay, for b, in order to make it a perfect square trinomial, the third term has to be 4, which means that we have to add 2 to both sides. So we end up with x squared plus 4x plus 4 is equal to 10, or x plus 2 squared is equal to, this should actually be just 10 here, and that gives us x plus 2 is equal to the square root of 10, and we get x is equal to negative 2 plus the square root of 10, or negative 2 minus the square root of 10. For c, in order for it to be a perfect square trinomial, we have to have a third term of 16. So we add that to both sides. We get x squared plus 8x plus 16 is equal to 32. And that gives us x plus 4 squared is equal to 32. X plus 4 is equal to the positive or negative square root of 32. So as our solutions, we get x is equal to negative 4 plus the square root of 32, or negative 4 minus the square root of 32. For d, same idea. We take negative 12, take half of it, square it, get 36. That means we have to add 15 to 21 to get it to 36. So we have to add 15 to both sides. So we get x squared minus 12x plus 36 is equal to 15. When we factor, we get x minus 6 squared is equal to 15. So x minus 6 would have to be equal to the positive or negative square root of 15. X is equal to 6 plus root 15, or 6 plus root 15, 6 minus root 15.